Standard computers store memory by flipping magnetic bits on a fixed grid, leaving the physical shape of the hardware entirely unchanged. For decades, neuroscientists assumed the human brain operated on this same principle. They believed we were born with a fixed set of wires, and that learning was simply the passage of data through those permanent routes. We now know the brain is an autonomous, self-modifying machine that physically rebuilds itself. This process is neuroplasticity, the brain's mechanical ability to physically reorganize its anatomical structure and rewire connections in response to new data. When you learn something new, it literally triggers a real-time physical hardware reconfiguration of your brain's entire internal network. When you learn to play a chord on a guitar, you are forcing an electrical signal down a specific sequence of neurons. During your first few attempts, the connection between these cells is incredibly weak, leading to slow and inefficient data transmission. In 1949, Donald Hebb proposed a principle to explain how the brain overcomes this weakness, a concept now known as Hebbian Theory. His theory identifies a mechanical absolute. Neurons that fire together, wire together. Repeated data flow serves as the direct trigger for structural network upgrades. This persistent strengthening of a chemical synapse through high-frequency activity is called long-term potentiation, or LTP. LTP involves the literal construction of high-speed biological cable across the synaptic gap. To catch the increased data volume, the receiving neuron physically sprouts new geometric receptors. Simultaneously, the transmitting axon physically thickens to handle the massive expansion in bandwidth. Mastery occurs when you have forced your brain to expand its physical infrastructure until data transmission becomes instantaneous. Building and maintaining this infrastructure is expensive. The brain consumes 20% of your body's total energy. Maintaining physical hardware that routes no data creates an unacceptable energetic liability for the body. If you stop using a learned skill, the corresponding neural cable goes entirely dark. To optimize the network, the brain targets these inactive routes for elimination through an automated process called synaptic pruning. The brain deploys specialized hardware removal units to manage this critical cleanup. These are microglia, aggressive biological waste disposal units that serve as the central nervous system's immune cells. Microglia physically track down the dead synaptic connections previously identified during the pruning phase. Through phagocytosis, they eat the hardware, dissolving the unused cables to reclaim biological energy for the rest of the network. Forgetting involves the active, violent, and physical dismantling of your own brain's architecture.